In this video, I'm going to show you how you can save scripted objects. Scriptable objects are not serializable. You cannot save them to binary. That sucks. If you want to save the scripted object that's assigned to each fish and allow it to persist between loads, well, that's what we're doing in this video. Let's jump right into it. Alright, so first I want to show you what I'm starting off with. Of course, I already have scripted objects created. It's just a bunch of fish. I created a tutorial on how to create scripted objects. You could go ahead and check that out. It's very easy to do. And also, I just have a spawner that spawns a random scripted fish. This is the spawner script. It allows me to spawn a random fish if I press the mouse button while I'm pressing the S key, and of course some fish sprites and a fish prefab. So the first thing that we're going to do is go ahead and create a C# script, and this is going to be our save game manager. So save game manager, and we're also going to make a static save class that does the saving, but this class just handles all of the saving and loading events. So open that up. And we're not going to be using coroutine, so we don't need this namespace. And we're going to be using lists, so we need this one. And we're not going to need start or update. This is a mono behavior because this is going to be on a game object. Which reminds me, go ahead and go into Unity, create a game object. You can name it save game manager. Just make sure it's the same name as your class. For good practice, reset the transform and drag your save game manager component onto it. Again, open it up. So what we're going to need is a list of all of the fish that we need to save. So we're going to make a public static list. There's that namespace we're going to use. And it's going to be a list of fish. You're probably very likely to be saving something else. I'm going to call it fish is equal to a new list of fish. You have to initialize the list here. And I would say fishes, but I think fish is already the plural version of fish. Look at all those fish, you know? Anyways, now that we have the fish, I'm going to jump into my fish class, fish.cs, and I'm gonna collapse my wander code in here. And all this code is over here is we take in the scripted fish, and on start we set our name to the scripted fish's name and the scripted fish's sprite. And if we take a look at the scriptable object here, this is literally what the scriptable object is. If you're watching this video, you probably know how to deal with this stuff. So in the fish class, I'm going to create a public function. So it's going to be a public void initialize, and it's going to do that. Don't want that. Okay. So in this function here, all we're going to do is add ourselves to the list of fish to save. This is the fish that the save game manager is going to save. So every time you spawn the fish or respawn the fish, we need to add the fish to the save game manager. And whenever you want to delete the fish or stop saving the fish, you simply remove it from this fish list. So we're going to go save game manager dot fish dot remove. I don't know why, but I accidentally said remove here. Replace remove with add, because we need to add to this list. I fixed this later in the video. Since this is the fish class, we just simply go this. And the reason we can have a reference to this fish list is because the list is static. Because it's static, we can get a reference to the list without needing a reference to the save game manager. Awesome. So now with this initialize function in my spawner, I actually need to initialize the fish when it's instantiated right here. So I created a fish called fish. I instantiated a fish prefab that is serialized in the inspector. Over here on my spawner, I have this fish prefab as well as a list of the scriptable objects that the fish can have. So all I do is say fish.initialize, and it'll add itself to the list so that it can be saved. Now we're going to create a save and load function. So void save and then a void load. Oop, not that. Just like that. Now in the save function, we want to iterate through all of the fish and save each of them separately. So I'll create the save system class in a second, but right now we need a path where we're going to save this fish. So constant string fish key, and I'm going to set it equal to /fish. So this is going to be the name of the save file that is going to be created. So now that we have the key, we'll just iterate through all the fish. So we'll just go for double tab I is less than fish.count, and now we need to save the fish. Now we're going to pass this responsibility down to the save system. So now we'll have to go ahead and create that class. jump into Unity and just create a C# script, and I'll call it save system. Go ahead and open that up. Alright, so now this is where we jump into the nitty gritty. This is the save system. This is the saving and loading. Guys, it might be daunting at first, but with a little bit of practice and repetition, coding saving systems will become very easy. It wasn't easy for me at first, so I don't think we're going to need coroutines or lists, so I'll just remove both these namespaces, and we won't need start or update because this is going to be a static class. We can't even use those. Now we want to remove mono behavior because this is not going to be on a game object, and I'm going to mark this class as static so that nothing will need a reference to it. So now just create the save function. It's going to be a public, and it has to be static because the class is static. So static void, we're going to call it save, and we're going to drop our brackets. Now what the save requires is a key for the path and an object. So what object are we saving and where are we saving this object? But what we're going to do is make it so that we can save any generic type. So the way that we would do this is in angled brackets before the parentheses, just pass in your type name, T. That's the most common name for generic types. And in the parentheses, we'll pass in an object of type T and call it obj. And the next thing that we're going to pass in is a string key. So since we're saving to binary, we're going to need a binary formatter. And to access the binary formatters, we need to use that namespace using system runtime. Dot serialization dot formatters dot binary. Can you believe I remembered that off the top of my head? So this allows us to access the binary formatter. So in here, just create a binary formatter, call it formatter. Come on, can I type? Is equal to new binary formatter. So next we need a string path for where we're going to save this object, and it's going to be equal to application.persistent data path. Now why application.persistent data path? Because different operating systems will require different paths, and this literally just throws that problem out the window. So now we're going to add on to this path the name of our folder. So we're going to put all of these objects in a folder, and I'm going to come up here and create a constant string, call it saves path, set it equal to /saves semicolon, and now we'll just add the saves path onto this. And now to save this folder, we need to be using system.io in out so that we can access files. And now we can go directory.create directory at path. Now every single time you're going to save, it's going to create this directory, but if the directory already exists, it will not create one. Instead, it'll just use that directory. And now we need a file stream. So file stream, I'm going to call it stream is equal to new file stream. And the file stream takes in two things. It takes in the path. So we're going to add the path plus the key. So it's going to put it in this saves folder, and it's going to give it the name of the key, comma. Next is the file mode. So it's going to be file mode.create, obviously, because we're saving. And now we need to use this formatter to serialize this file stream and actually save it. So we're going to go formatter.serialize, and we want to serialize this stream with this object into it. So obj, we'll just put that in right there. Now keep in mind that this object has to be serializable. Next, do not forget this step. We have to close the stream. So stream.close. If you don't close it, this is not going to work and you're going to get some pretty weird errors. That's pretty much it for the save function. Now we need to create a load function. So we're going to create a public, again, static. And this is going to be of type T. It's not going to be void. It's going to be of type T. And it's going to be load. And obviously we need that type again, parentheses. And since we're loading, the only thing we need is the key. We're going to pass in the string key here for the parameter. We just need the key to point us at what we need to load. And then we return that. So I'm going to copy all this code here and paste it into here. And we're not going to create a directory, but we're going to keep the same path, make sure the path is the same, creating a formatter again. But now what we need to do is check if the key actually exists. So we're going to create an if statement, and we're going to check if file.exists. We're going to check if file exists at the path plus this key. And if it does, we load it. Else, we'll just debug.log error and say save not found in plus path plus key. But if it does exist, now I'm just going to take this code and put it in here. Now the stream is going to be the same, except for we're going to go file mode.open because we're not creating a file, we're loading it. And now up here we're going to create a variable of type t. I'm going to call it object. And we're going to set it equal to default. And what default is just the default value for whatever type was passed in. And in here, we're just going to replace this with object is equal to formatter dot deserialize this time. So we're taking it out of the file and we want to deserialize the stream. Now it's going to give us an error because we need to specify what we're deserializing it as. So in front, I'll just pass in parentheses type t. And now finally, we return the object. Now if the path is not found, because you might have some scenarios where you restart the game, you need to create the first save, and of course that's not going to be there. So in order to work around this, we can just create a public static bool and call it save exists. And it's of type bool because it's going to return true or false whether a save exists. And we're simply going to return file.exists at the passed key in our parameter, and we'll have to create a string path, and the path is going to be equal to the same path here. So go ahead and paste that in here, and we're going to check if the file exists at path plus the key that we're checking. And why do we return this snippet right here? Because this is also a bool, and if it exists, it returns true. If it doesn't, it returns false. So now you can check if the save exists if you ever want to check before you load something. And really, now that I think about it, we should rename this to data, because we're loading data. So now the save system is created. That's literally all we need. And if this looks a bit confusing and hard to understand, trust me, I know, I've been there. With practice and repetition, you will get used to it. So now we jump back into the save game manager. Now all we have to do is create a string key. It's going to be equal to the fish key. And if you want every object to be specific to every scene, and what I mean by that is if you have tank 1, 2, 3, and so on and so forth, if you want to save the objects to each specific scene, all you have to do to the key is add onto the key the build index. And in order to get the build index, we'll go up here and say that we're using hello.
Hello.
Hi, Katrin. You're mid video.
Can I be in the video?
Yes.
Really?
Yeah.
How much longer?
Probably takes me like 20 more minutes.
20 minutes, baby.
Wait, what'd you say?
No.
Something 20 minutes?
I'll call you in 20 minutes, baby.
Okay.
The clock starts now.
Okay, bye. We need to be using Unity Engine.Scene Management. Now we can add onto this key plus scene manager dot get active scene parentheses dot build index. So literally the build index, add it onto the key so that it saves to each scene. Now that we have the key, we need to go save system dot save. Now we cannot simply go fish at the index of I just to save that as the object, and it would be messy to save each variable separately of the fish. So we're going to put the fish into a data class and save the whole thing instead. So I'm going to comment this line out, and we're going to jump into Unity, and I'm going to create another C# script and call it fish data. Now bear with me guys, this is going to be a simple data class. We're not going to be using these two namespaces. This will not be on a mono behavior. We will not be using start or update. First and foremost, this must be marked as system.serializable. No. System.serializable. So we're going to create a public fish data. It has no name. It's just going to take in the name of the class. And in the parentheses, we will pass in a fish named fish. And now we're going to create some variables. This is going to be the variables that we want to save. So I'm going to create a public string. This is going to be the scripted fish name. So this is going to be the name of the scripted fish's asset name. We want the name of this asset, not the name of the scripted fish. We do this because we're going to load this stuff from a resources folder. And the next thing that I want to save is going to be a public float array. I'm going to call it position. Now the reason we're not using a vector3 is because you cannot serialize or save Unity specific things such as vectors, quaternions, or colors, but those can be easily broken up into a float array. For instance, for the color, you can save the RGB and alpha, so that will be a float array of 4 elements. I think I'm talking too much. It's really not as complicated as that as it sounds. This scripted fish name is going to be equal to the fish.scriptedfish.name. Now we have an issue here. If you go to this name and go to the implementation, this is the name of the variable name, not actually the asset name. So what I want to do is just rename this to fish name. Now that it's not named name, we can remove this new keyword. And now we can jump back into our fish data class, and we don't want the fish name. We want the name of the asset. And now we're going to create a vector3, call it fish pause. It's going to be equal to fish.transform.position. Now, why did we just cache this in a vector3? We are not saving this vector3. What we are doing is caching the position so that I don't have to access the transform position 3 times separately for the X, Y, and Z. So now I'll initialize this position and I'll say position is going to be equal to a new float array. And in here, we're going to drop our brackets. And in here, you just simply add the elements. So it's going to be fish pause dot X for the 0th element because it starts from 0. I don't think 0th is a thing. So it's going to be X, Y, Z. So fish pause dot Y now and fish pause dot Z. Now you put the semicolon on the bracket. And now that is it for the fish data class. Finito. Jump into your save game manager and we're going to uncomment this line out. We're just going to remove this here and we're going to create a variable of type fish data. We're going to call it data. It's going to be equal to, and this is where we access that constructor. Guys, I love constructors. So we're going to access that constructor. It's going to be equal to new fish data. And if we jump into this fish data class one more time, you can see that this constructor literally just takes in a fish. And when we're creating a new fish data, we just pass in this fish at the index of this iteration. And when we do this, all of this code is going to run for us whenever we create the new fish data. So on save, we just pass in the data and the key is going to be key plus the index of this iteration, so I. So in order to save multiple objects, you have to add the index of this iteration. All right, that's literally it. So now let's copy all of this and jump into the load function. Key is going to be the same. Make sure you copy and paste the key. And we have one problem here. Once you save and turn off the game and reload the game, this fish list has reset. And you can see in our load function that we are actually still trying to access the fish count even though that list reset. So what we have to do now is save the fish count. So back to our save function, we'll create a string count key. Now up here, I'm going to copy this constant string and paste it. And I'm going to call this fish count key. It's going to be equal to fish.count. That's literally just the file name. Now the count key is equal to fish count key plus the build index. We do the build index so that we can save to each scene. And now we simply go save system.save fish.count. That is what we are saving. This is going to be saving as an integer at the count key that we created. And that's literally it. It's saved. Nice. And now in the load function, we need to load the fish count. So we'll just copy this count key and paste it into here. And we'll create an int. Taking a little longer than I expected.
My goodness, 20 minutes is up.
Okay, hold on. I'll call you back.
How much longer?
Probably another
30 minutes?
30 minutes.
I guessed it.
Yeah. Alright, bye. Gotta go.
Bye, gotta go. My goodness.
Alright, I'll talk to you later.
I love you.
I love you too.
That's gonna be in your video.
Oh, we'll see about that. And now we're going to create an int. This is going to be the count. And it's going to be equal to Again, save system, we're going to say load. And now we actually have to specify the type. This is of type int. And in the parentheses, we pass in the count key. So when we save, we didn't have to specify the type that we are saving because we passed in this object. Unity was smart enough to understand what type it was here. But here we had to specify that it is an integer because we didn't have anything to put in for the function to reference as a type. So now with the count saved and loaded, while I is less than count, and now the fish data is not going to be equal to new fish data, going to be equal to save system dot load. We want to specify what we're loading fish data, and pass in the key plus this iteration, and we can just remove this line. So now that we have the data, we actually need a fish to take in this data. So we're going to need to instantiate a fish. So I'm going to create a fish called fish. It's going to be equal to instantiate. Now we need a fish prefab. I'll just go up here and create a header and call this prefabs. And then serialize a field, and it's going to be of type fish called fish prefab. I'm going to comment out these two lines so we have no errors. Save the script, jump into Unity, and you can see now on our save game manager we need a reference to the fish prefab. So now I'll go ahead and reference the fish. So now that we have the fish, we can just instantiate that fish prefab. So now we need the fish to load all of this data, but I'm going to make the fish class do that on its own. So in here I'm going to create a public void and call it load. It's going to do that again. I don't want that. And this load function is going to take in fish data. I'm going to call it data. Now we need to recover our scripted fish. So scripted fish is going to be equal to resources.load. And now how resources works, basically what you need to do in Unity is in your assets folder, create a new folder called resources. Make sure you spell that correctly, and whatever you're loading from resources, you need to put inside of the resources folder. Now we need to drag all of our scripted objects into that resources folder. I just realized that this says remove. We need to add to the fish list. And now I can actually copy this code here. Now in this load function, we actually don't need to set the name and the sprite renderer sprite, because all we really need to do is get this scripted fish, and on start it is going to load the information of the scripted fish because load happens before start, but we're doing it anyways just in case something doesn't load for you. And now we need to recover our position, so I'll create a vector 3, call it position, and it's going to be equal to new vector 3. Now in our fish data class we created this position float array. And now we need to say the x is equal to data dot position at the index of 0 for the x. We'll just copy this a couple of times, one for the y and one for the z. And for the y, that's at the index of 1 and 2 for the z. Now we need to use this position, so we'll say transform dot position is equal to position. And that's it, guys. And now that we have the load function created, go jump into your save game manager and say fish dot load, and we need to load the data, this data that we loaded from the save system. And we also need to say fish dot initialize so that it re-adds itself to the fish list. And now we need to actually call these functions. So when will we save? Well, you can choose to save whenever you want to, but I'm going to save on a callback function. So void on application quit. I'm going to remove the private keyword. We're just going to say save. Now, if this is on an Android, you would simply say void on application pause. Then you would say save. Now we have to use on application pause for Android because it says that there's not a guaranteed callback for on application quit, but there is one for on application pause. Okay, so you have to put that save function in an if statement checking if pause is equal to true, then you save. I don't want to re-record this video because it's really long. And every time you need to load a scene, if you need to save, then just make this save function public and get a reference to the save game manager. So before you load the scene, you need to save. And it would look something like this. Here's your function, just imaginary function. You would just say save. And then on the next line, you just load the next scene. And when do we want to load? We just load on awake. So void awake. Go ahead and say load. Now if this is going to be your first time loading, there's going to be nothing to load, so it will throw an error. Go ahead and save your game, jump into Unity, and everything should be ready to play. Now there's that error that we have, save not found in our path. So now we can actually spawn some fish. And here's the exciting part, unload, reload the game. Ta-da! We have a bunch of beautiful fish with their scripted objects. Thank you guys for watching. I hope this video helped you out. If it did, be sure to subscribe and like the video for more content like this. With that being said, I'll see you guys next time.
Like and subscribe.
What? Are you hypnotizing my viewers?